Hello students, this is Yashodhari. In this video, we learn about the shearing transformation. Okay, in last video we covered reflection, scaling, rotation and translation. In this video, we know about the how the shearing operation will be done in a computer graphics. Okay, let's start. Okay, what is the shearing meaning? Shearing here the previous two transformations, namely scaling and reflection, used only the diagonal elements of the matrix. Means whatever we learned in the last videos, we are learn how the scaling. Scaling is nothing but we are increasing or decreasing the size of a given object, right? We can increase or decrease in the size of a given object, that is a scaling. What is the reflection? Reflection is the rotation, means changing the angle in a 180 degree, means it's a reflecting, it gives a mirror image of a given object, right? So it's directly gives, means mirror error means a 180 degree or you can say a 90 degree. So what about the diagonal? How the shapes or whatever the polygons we are taking, we want to tilt, that means it will be off diagonal. The shearing will be the process where the transformation is done by the of the polygon, or you can say image or picture that gives in a off diagonal, means they may be a slightly bend with the some particular x-axis or a y-axis. Okay, that is called a shearing. Okay, so how its shearing will be done, we will see. Okay, so first, a shearing is a deformation of an object in which parallel planes remain parallel but are shifted in a direction of a parallel to them. Okay, so here we are taking the sharing on x-axis or y-axis. The shear changes the quadrilateral to a parallelogram. Means this is an example. Okay, shearing refers to change in the shape or simply deformation of an object or image. The matrix will be the formula of a p dash equals to p into of shear. P dash is nothing but your change the object coordinates of a x and y. P is the original object's coordinates of a x and y. The shearing will be where share in the x direction or a y direction. Shearing a geometric transformation that slants. This is word. The slant means little bit bend with a diagonal. Okay. An object by shifting its coordinates along one or more axes, causing it to appear skewed. It changes the angle between lines but preserves the parallelism of a line, and it can be applied in both 2D and 3D environments. Okay. In 2D, this involves a shearing along x or y axis or xy axis. Okay. With the example, first we have to make the a matrix. How we have to represent the shearing in a matrix, we will see. Okay. So 2D shearing on x-axis or a y-axis, we see. X shearing, the x coordinates of the point is shifted by an amount proportional to its y coordinates. What it means? The equation is x dash equals to x plus shearing of x multiply with the y coordinates, and y is same as the y. Y dash is equals to y. Means if we want to share the on x-axis, it will changes will be done in a x coordinates only. Y coordinates is remain same. Okay. So how we have to write the matrix here? This is a P. This is P dash. Okay. That is a x dash y dash coordinate. This is your P, that is original object's coordinates x y, and multiply with the shearing. Here we are done in a x-axis, right? So for this is x, we have to multiply sharing object of x is y. That's why sharing of x is here, and here the 0 because next y is not doing anything. Y has the same as the previous one. Okay. This is your x-axis sharing, means this is your original. Okay. Here the object get changed x to y, x dash, right? With the example, we could clearly understood how it performs. Okay. So y sharing, that means y sharing means y will be changed and x coordinates will be same as the original one. Okay. So matrix will be here x dash y dash x into x y in multiply of a 1, here 0 sharing of y into 1. Okay. So this is how we are sharing will be done in a parallel of a y. Okay. Here the sharing will be done on a axis. Okay. So here we are discussing with one example of a given ABCD. Find out the new coordinates of the object along x-axis, y-axis, and applying shear parameter 4 on x-axis and 1 on y-axis. Remember, here they are giving shearing parameter of 4 on x-axis, means that is the shearing of h of x is given as a 4, right? So the given is original square with the points, what they again? A, B, C have listed. Okay. So here we taking the next of sharing parameter x-axis is 4. They are mentioned here, the given. So y is 1, right? On we have to applying on x-axis. For the formula is x dash equals to x plus sharing of x multiply of y. Okay, y dash. We are applying on a of 1 comma 1, means a dash we are getting. This is the original one. Before the sharing, the object is like this. Okay. So we have to apply on a x-axis. So put the given value in a equation. We get here a having a 1 comma 1, means x equals to 1, y equals to 1. How to put the values? What is the SF sharing of x value? That is 4. Okay. So we have to put the value, all given values, 1 plus 4 into x into of y, that is 1. So what we get? 5 as your x value, and y is same as what we are given, that's 1. So a dash value is, a value is 1 comma 1, but what we get a dash, that is a 5 comma 1 for the sharing on x-axis. So like this you have to take the all the ABCD dash value, means after sharing we get the B as a 7 1, C as a 15 3, and D is 13 comma 3. Means we are just applying the x and y values with the sharing is a 4. Sharing of x is a 4. Just we have to multiply, and y value should be same as a given. That's why we got this one. A dash is 5 comma 1, B dash is 7 comma 1, C is 15 comma 3, D is 13 comma 3. Now put on the graph. Look, this is your a sharing of a object. How that share? That sharing on a x-axis of a 4, right? This is how we have to do the sharing on a given object's parameter. Okay. I hope this is clear. Just we have to take the original one, how the whatever the data is given, according to how to draw the figure, then putting on the which axis they want shape, they have to use the formula and calculate the values and put the graph. So we easily understood how the parameters get transformed, right? That is, this is a sharing of a on x-axis. similar example we continue on a shearing on y-axis. Okay, so same figure we have to, but we are taking the shearing parameter along y-axis, that given is a 1. In last slide we saw on x-axis shearing will be applied on a x-axis, that is value is given 4, here 1. So this is the basic of figure. How we have to find out the y-axis shearing, that is x will be similar as the original one, and y we have to take the equation y dash equals to y plus shearing of y into of x. Okay, first term a dash we have to find out, x equals to 1 and y dash is we get a 2. Y is 1 plus shearing of y value is 1 into of x is 1. That's why we got a 1 plus 1 into 1 is 1, 1 plus 1 is 2. So a dash we got a 1 comma 2. X is 1, y is 2. And b dash nothing but a b is a x of 3, y of 1. So applying the shearing on a y-axis, so 1 plus 1 into 3. Shearing of y is 1, and what is the value of here? Y is shearing of y into of x is 3, right? X value is 3 for a b. For 1 plus 1 into 3 is 1 plus 3, and y we got a 4. 3 comma 4 is your b dash. Like this we have to calculate the c dash and d dash. What we get as c dash? 3 comma 6. What is the original 3 is 3 comma 3. Okay, here 3 comma 6. Y values have got changed because of we applying a shearing of parameter on a y-axis. So for this, what is the how we have get the shear? This is a parallel line of changing. Okay, this is for shearing on a y-axis. Okay, so what if we have to shearing on a x, y both the coordinates? So how the with the same example we have to forward the x, y axis shearing, means we have to move shearing with the along x and y same. Okay, means with simultaneously we applying on a x and y shearing. So first we have to apply the x shearing, then we have to apply the y shearing on the applied x shearing values. Means first we have to find out the x shearing and then we have to apply the same value y with the y shearing. Okay, so this is first time we are calculating a dash. So how we have to do? First apply on the x-axis, we got the x value as 5, y is having a similar as a 1. So after this we have to take the y value as in a y shearing, because x is similar to x we got in a x shearing is 5, then y is having a 1, that y you have to take in 1 plus shearing is 1 and x value is, now you got the x value from the this x shearing, right? So 5. So we got the a dash as a 5 comma 6. Okay. So continue with the b as well. B shearing with the on x axis is 3 comma 1. We got a x as a 7, y as a 8. Okay. Whatever you getting by the x value from the x shearing, we will taking with that x value in a y shearing. Okay, remember this one. So we get this is a how the shearing will be applied on both the x and y coordinates. Okay, this is how the shearing of object will be done. Okay, this is a transformation, 2D transformation will be complete here. We will continue with our class. With the next class we see a homogeneous factor, and then we move on to the 3D transformation. Okay, so I hope all the concept is clear for everyone. We will see in the next video. Thank you.